Uh, Thanks for coming to the Jones Seminar this week. I'm pleased to announce or introduce our guest speaker today. It's Professor Jim Hendler. Jim's got a long bio that I can't read the whole thing, but I'll read the significant parts, the highlights of it, and then tell you a few words, editorialize a little bit. So Jim, first of all, Jim is known for his contributions worldwide to the semantic web concept, and he'll tell us more about that today. Since 2007, Jim has served as the Senior Constellation Professor of the Tetherless World Research Constellation at RPI. So it's a very interesting arrangement that they have at RPI where they set up constellations and constellation shares, and Jim was the founder of this one constellation, the Tetherless World. Jim also has appointments in computer and cognitive sciences, and he's the Assistant Dean for Information Technology at RPI. Prior to these appointments, Jim was a professor at University of Maryland, where he was director of the Joint Institute for Knowledge Discovery. At Maryland, he held joint appointments in the Computer Science Department and the Institute for Systems Research. He's a former member and actually currently also a member of the U.S. Air Force Science Advisory Board and a former chief scientist of the Information Systems Office at DARPA. He's editor-in-chief emeritus of IEEE Intelligent Systems and is the first computer scientist to serve on the board of reviewing editors for science. Jim earned his bachelor's degree from Yale, his master's from SMU, and his PhD from Brown. His other honors include a Fulbright Fellowship. He's a fellow of AAAI. He's a fellow of the British Computer Society and the IEEE. So that's some of the formal stuff. Informally, I've known Jim for about 15 years, and in my mind, he's got two outstanding attributes that will come across today. So first of all, he's extremely enthusiastic about what he does, and so his enthusiasm is contagious. The other thing is he's persistent. So some of the ideas that Jim will be talking about, I think you started thinking about them 10 years ago in some form or another. And in my opinion, there was a lack of interest in some of the American funding community, and so really the center of gravity for this work seems to have moved to Europe temporarily at least. And Jim is stuck with it, and it's making a comeback here, a very important one that I'm sure you'll tell us something about. So with that introduction, Professor Jim Hendler.
Turn that off. Okay. So interestingly enough, I chose not to talk about all that stuff. And there's actually a reason, which is that, as George mentioned, some number of years ago, we started trying to convince industry that paying some attention to this sort of semantic stuff on the web would be a useful thing to do. And then I spent, 5 or 6 years giving talks which said, here's this crazy idea, you guys really should listen, it's going to be important. Then, and no one would have listened to me, but luckily Tim Berners-Lee, which now a few of you in the room at least know. How many of you know who Tim Berners-Lee is? This is actually, see George, I told you the non-engineers would know better. Tim in 1989, 90, depending exactly what you want to date it to, wrote a computer program called World Wide Web. It's actually doing pretty well. Some of you probably heard of it, I think. So Tim is unquestionably the inventor of the web. He invented the primary protocols it used. He's now he's a professor at MIT and the University of Southampton, and as of a few weeks ago, also Oxford. And he heads the World Wide Web Consortium, is on the board of directors of what's called the Web Science Trust, where I'm privileged to serve with him, something called the Web Foundation, and a few other things. He's won a couple of awards for having created this stuff. And so luckily he was talking about the stuff too, so people paid some attention. And it's taken a while, but you know, the amount of time it takes something to transition from a crazy research idea to where it starts getting out into industry tends to be, depending who you listen to, 8 to 12 years, and depends whether you're talking early adopters or the first large companies. And we're actually at that point now with this technology. So the stuff called Semantic Web, Semantic Technologies, is now supported by companies you've probably heard of. There's one named Google that's using it to promote semantic search. They were pushed into this by a new search engine called Bing, which came out of a little company called Microsoft. The really big change was the one that I think really legitimizes us is last week, actually about 2 weeks ago, a new what's called the Open Graph Protocol was created by a little company called Facebook. It's based on a language called RDFA. I won't give you any details about it except to say it grew directly out of the Semantic Web language. Major governments all over the world are now releasing their data in what's called linked data formats. Linked data is what we proposed 10 years ago. So it's successful enough that it seems to me it's really dumb to come out to academic talks and tell you about it, right? What I should be doing now is trying to get that crazy research vision thing going again and talk to you about what none of you should believe me is right for another dozen years or so, right? Particularly for the students, because if I can convince some of you, you guys will be the leader. So, you know, who's making the money off the semantic web stuff? It's not, you know, sort of us old professors who suggested it and evangelized it. It's the people who were smart enough to realize we had a good idea and turn it into industry. And so I'm hoping maybe some of the ideas I give you today will spark some of those good ideas too. Also, you know, that stuff has become known in the outside world in some circles as Web 3.0. So if I started working on what's Web 3.0 before Web 2.0 existed, right, I'd better be working now on Web 4.0 or Web 5.0, not Web 3 if I'm going to stay ahead of the curve. So a few of us got together about 3 years ago, and it was actually a fun group. And I won't go into the details of how it happened, but I found myself in a room with Tim Berners-Lee, who invented the web, John Kleinberg, who I know a lot of you have heard about, does a lot of the math of social networks, a guy named Louis Van Ahn, who's the person who invented games with a purpose and things like that. And we were talking about, you know, sort of the usual stuff geeks talk about, crowdsourcing and web stuff and things like that. And I forget whether it was Louis or Tim said, you know, here's a good research question. Supposing you had $1, you know, to invest in crowdsourcing or Amazon Turk or something, Mechanical Turk or something, you know, how are you best to use it? You know, should you give 4 quarters or $1 or 100 cents? And Tim said, that is a good question, but here's a better question. How do we use the web to cure cancer? And there was that same silence that you just had. Now, when you're in a room full of MacArthur winners, and one of the guys says something like that, and you get that kind of silence, the chill goes up your back that something interesting is happening. So separately and together at various times, and now I transitioned primarily in my work, although I've done some of this jointly with Tim, and there's a couple papers we've written together about some of the early stages of this. The idea started to form is, how do you use the web to cure cancer? Or let me put it a different way, right? So in 1999, in the book Weaving the Web, Berners-Lee said, computers can help if we use them to create abstract social machines on the web, processes in which the people do the creative work and the machine does the administration, right? And he coined the term social machine to represent this. Now, looking at that now, that doesn't look very interesting, but if you realize that the book was first written in 97, was 99 by the time it was published, you know, that's before Facebook, that's before Twitter. So these things weren't out yet, right? So the notion of what we now call social networking sites, right, was still just very, very much in its infancy. And I would argue that these things, which have so much changed our way of thinking about the web and life on the web and et cetera, are really very, very primitive early systems, okay? And that what we really should be thinking about is sort of the future of this. So here's where we stand right now. This slide is a couple months old, so it says 21% of the world's population uses the web. The number's closer to 24% now and climbing, but You know, I was at a talk where I used this. I was on a panel and I used this as a successful number, just to give you a, put that in perspective. That's a significantly larger number than the number of people who've ever read a book. That's larger number than the number of people on Earth who've seen a book, driven in a car, flown in an airplane, those kind of things, above flush toilets. And that's pretty amazing, right? On the other hand, the next speaker after me happened to be Berners-Lee, who got up and said, yeah, so that means there's 75% we haven't got this stuff in front of yet. So it's an interesting idea about your perspective, but that's aside. But now here's the much more interesting thing when you drill down on that number, right? So here's one website. You guys have heard of Facebook. By the way, one of these numbers is off by a few orders of magnitude, but I'll get it right in a minute. Facebook reports 4 billion minutes a day are spent on their site. Right, that's, you take the number of their users, the average use time, go to the Facebook stats page, you can find this. 4 billion minutes is 7,500 person years. So that's as if you had a company with 7,500 people in it working for you for a whole year. The thing about an IBM being 7,500 person years per year is wrong. It turns out to be per day mostly, but per 10 days. So it's an order of every day there's more effort spent on Facebook than the entire company of IBM has out working for it. Okay, but in a sense you could claim it's not productive time, or it's social time. It's very useful. A lot of interesting things happen. But now imagine if I had 50 people who are going to work for me full time, right? I got them every day. I can kind of figure out how to arrange them in a research group, and I can go out for cancer research funds, and I can think about how to cure cancer with those people. But if I have 100,000 people who will give me 3 minutes a day, I have the same number of minutes. What I don't have is any idea of how to use that, or any technology to really help me use that. So the question is, could we create technologies that make it possible to harness some of this social energy going on in the social network to actually solve some real world problems? So imagine if you could have hundreds of millions of people, the number of people working the web, effectively able to network together. Well, that, you know, Facebook, they can do that. But now working with the kind of data archives that science, governments, NGOs are starting to make available on the web. And now you could have subgroups who want to cure diseases, feed hungry people, empower powerless people, you know, improve the crime situation in their local neighborhood. So they don't have to be these huge scope problems. It can be little things, you know, solve global warming, whatever. You got the minutes there, you got the time there, but what we don't have is the technology. So essentially there's this kind of science fiction-y vision maybe of doing this. But the question becomes, you know, just how science fiction is it? So a very popular idea being proposed primarily by Google in talks called things like, you know, what you can do if you own all the data in the world. That may not be exactly what they call it, but it's close enough. You can do interesting things. So for example, this is CDC. So this is ex post facto CDC's reports on flu trends, and this is Google's. If you take the 50 terms most correlated with the searches that come out with the flu, in theory it does this. Right? Now there's actually a lot of limitations here, and I'm not going to spend my time bashing this particular result. It's actually not a bad result. But I mean, there's some issues with it. It's like, first of all, it's not predictive, right? So it's nice that after you have a flu outbreak, you can know that it was being predicted by Google. But actually, if you try to use this and say, is it predicting flu outbreaks really well, the answer is you got to kind of clean up the data. This is based on the 50 top terms. Turns out if you use the 10 top terms, it does terrible. It turns out if you use the top 100 terms, it does even worse. Why? Well, because sort of the first terms are maybe too specific, so most people don't know them. The 100th term is probably, you know, something general like ouch or hurt or ache, right? So, you know, those correlate with lots of things. So if you take a lot of this stuff and play with the numbers, you can get these really clean curves. And a lot of people are doing some amazing data mining, healthcare stuff, when you get the kind of things we can get to nowadays. So I know some guys who are working on, if you have a pacemaker, then when you go to your doctor's office once a month, it now dumps the information to their local machine. In fact, now a lot of that's happening through telemetry, so you don't even have to, plug in or anything. And you get a big company, a Medtronic or a Boston Scientific, and you get their data set, and it's a gazillion sensor readings over a course of a year or 2 years. And they have a lot of people looking at time course analysis and data mining and verification. It's fascinating and important stuff. But again, it doesn't quite feel right, right? The second, so can you do this somehow more purposefully, right? So not so much accident. An idea that has been very, very successful. This is actually one of the things Louis Van Ahn has done at Carnegie. Basically, a lot of you probably recognize this thing where you've gone to some web page and it says, will you please prove you're a human by typing these 2 words? Well, it actually turns out that if you type those 2 words, generally what you're doing is helping improve the state-of-the-art in optical character recognition for old documents. Because one of those words is a word that was actually known to the data set, so they're pulling it from a database. And the other one is they're taking the scan and slightly permuting it from a document where the OCR was not able to reliably decide what word it was. And then if you get the second word right, they sort of assume you probably got the first word right, and you use a lot of people in that. So about 400 million people, which is 6% of the world's population, have used this thing now. So I do have to put the word unknowingly in quotes up there because Louis gets very, very angry at me if I say unknowingly. Because if you go to the site, you'll see there's a little thing you can click on. If you click on it, it'll tell you exactly what's happening that you're helping. I haven't yet met anyone in an audience of mine who, without having read the paper first, ever thought to click on it and see. But essentially, so you've been helping Google do a better job of scanning old documents, and Google's been helping you by putting more of those old documents online. So it was a good deal. Probably more of you have heard of games with a purpose. This was Louis's other big idea. A lot of Google images got marked up by a game. So you show the image and you ask you find 2 random people on the web and you say, write the words you can say, and as soon as you've got sort of one that matches the other person, you get points the faster you do that. And you can run up points together, and you get team scores and individual scores. And he's done about 20, 5, 10 of these that have been popular. Many, many people have tried to imitate this. There have been a few successes, a lot of failures. So we still have a long way to go. Seems to be more of an art form right now than a well-known thing. So any of you graduate students who are planning to, just do one of these because they're hot right now, should know that most of them don't work, and that the real research, I think, in this is figuring out why Louis's ones work and everyone else's don't. That's not everyone else, many other people. But there are things now called games with a serious purpose and things like that. So for example, the most famous of what you might call a game with a serious purpose, this one's not a game per se, but they work more or less the same way, is something called Galaxy Zoo. Is it possible, George, to get these lights turned down a little? Because some of these slides are going to be really hard to see without a little more contrast. No, I just wanted people to be able to see. That's good enough. Thank you. So this was some work that's been done by a big team. It originally came out of Oxford University. There's a group at Harvard who joined in. There's now people all over the world helping to build this thing. But essentially, the way Galaxy Zoo works is you can go to this website, galaxyzoo.org, and what you do is, so the Hubble space, oh gosh, now I'm blanking. But there's a sky scan going on all the time. So what's happening now is each night, big telescopes are being pointed at essentially deep space. And they're just covering the space and doing it over and over again. The Getty sky scan. So what they've been doing, and then you get pictures of lots and lots of galaxies. And it turns out it's not hard for a computer to identify that a picture contains a galaxy. But what's really hard is, right now in the state-of-the-art in vision processing or graphics processing is for computers to tell what kind of galaxy it is. And there are really 2 main parts. One that's sort of a sphere and one that's sort of the pinwheel. So those two shapes. Those two shapes. Right? So a fat one and the one like the Milky Way, the stuff we're in. You're used to seeing that. But people turn out to be really good at it. So what happens, and then there's some variance in which directions and things like that. So what happens is you sit there, you look at this stuff, and so if you register on the site, you take a 5 or 10 minute training, you learn to do it, and then whenever you feel like you can come, it'll show you galaxies. Okay, and then you say which kind it is, and this is way out of date. This was from 5 weeks ago. And again, if you turn it on, so this is the Zuneometer. If somebody in the audience has a machine with them and wants to check Zuneometer, it'll show you what the new number is. It passed 60 million a while ago. You can actually, as you sit there and watch it, you'll see the number move. People all over the world doing it, hundreds of thousands of users. Okay, so here's a group that has figured out how to use a few minutes each of hundreds of thousands of users to do something useful. Right? And in fact, it's turned out to be very useful because classifying that is an important astronomical phenomena, and getting that number right is important. And it doesn't, of course, just show one person, one thing, and take whatever they say. It does cross-validation. It does things. So a lot of technology lives underneath the hood to make sure it's right. So they have a whole team of programmers who keep this thing alive now. There's a graduate student at Oxford who's been actually comes out of the one of the sociology departments, and she's actually been meeting now with the team and is trying to figure out sort of who does what. Don't try to understand it, but notice all these overlapping circles. Those represent what's controlled within the group that's doing this, what's general population, what's scientific population. A lot of interesting things in there. What kind of technologies are being deployed where? So you can see there's, the people who are actually getting the stuff off the Hubble are all really pure astronomers, and by the end you're down to the public who are, sort of 10 minutes of astronomical training but want to play. Well, here's one of the most interesting results that has come from Galaxy Zoo. You can't go to a Galaxy Zoo talk without hearing about this. It's called Hanis Vitter, except I can't pronounce it right, so someone here can probably say it better than I can. But it means Hanis thing or Hanis object, right? And what happened is that picture was shown to this woman. This woman is a grade school teacher in the Netherlands who likes Galaxy Zoo. And so every morning for a few minutes before she goes to teach her 6th graders, she would get on and she would play with doing some galaxies. And one day she was shown this picture, and one of the things you can do on Galaxy Zoo is sort of say, ask the scientist. So if you think you can't classify it because something's weird, or you see something else on it that you think is interesting, you can say, what's going on here? And so she kind of circled the green thing and said to the scientist, somebody look at this. Well, one of the scientists looked at it and said, I don't know what's going on here. And it generated a lot of interest, a lot of astronomical things. This is the first big paper on it. I should remember where it appeared, Physics Notes 1 or whatever. But if you look, you can see the 4th author is Hanny van Arkel. That's the grade school teacher. In fact, it's fun to look because you probably can't see it from where you're sitting. But number 1 is Department of Physics, Oxford. Number 2 is Department of Physics, Yale University, Yale Center for Astrophysics. And then for hers, it's the Netherlands school system. Now, you'll notice I called this either a digression or the whole point, right? So the really interesting thing about this is one of the reasons we don't know exactly why people do Galaxy Zoo, but we're pretty sure they don't really expect to end up published authors, but they do like the fact that they're contributing to astronomy. They're contributing to science. There's a lot of evidence for citizen sciences. Well, what about other things? So here's another thing you may have heard of. How many of you have heard of the human flesh search engine in China? Not arbitrarily, yeah. It's a terrible translation. It's actually the literal translation. Characters working with some previous audiences, we came up with PeoplePowered Search, which is much more effective and takes away a bad connotation. if you watched Law and Order a couple years ago, you know what this stuff is. You may not have remembered that they called it that, or read the New York Times magazine a few weeks back in March. But basically, there's been a lot of mythology about this stuff. It's basically a bunch of people in China who get together on the web using very informal things, chat groups, uploads, downloads, et cetera, and solve real-world problems. And in this one, it was a group of people used the web to commit a murder. And so, the Law and Order guys had to figure out, how do you prosecute 1 million people in another country? And luckily, it turned out it wasn't actually how it had happened, and it was some random person they could grab. The New York Times article is actually more interesting. It actually tells about what most people acknowledge is the first use of this, which was a woman in spike heels who did a YouTube video of killing an animal, right, a little dog, right? And what happened in China is people saw that thing and said, that's awful. Who is this woman? And it became a phenomenon. People started trying to figure out who she was, and they eventually found her. It took several days. Right, identified her, and she was basically ostracized from her community. I mean, it's not easy to be her anymore. I don't know what actually happened. And this sort of took off. This became a model. So some colleagues of mine in China, I've been working with them. They've done the bulk of the work because I don't read Chinese. But they've actually gone through a whole lot of search engines and chat groups, and they've pulled the data. They have found the traces of, now it's over 450 of these things. The data I have here is from December, so it's about 350. And what we've tried to do is actually, based on what we've seen, see if we can come up with something that's a little more technical in our description of what's going on. So I won't go through all of this in the interest of time, but roughly speaking, this is what we've come up with as the definition. So what you've got is a crowd behavior, a goal-oriented task, a combination of online sharing and dissemination, but the sources being not primarily online sources, including offline sources. So for example, people will often ask me, well, isn't Gmail just this? And the answer is no, because Gmail is primarily online and isn't really goal-oriented. Well, what about Mechanical Turk? Well, that's closer, but it still doesn't have that online-offline thing except for the initiator. So we've studied them. This was the curve as of end of 2009. It's now 6 months later, and the new one, so we have 112 more cases. The great bulk of them have been in mainland China. Second is Hong Kong, and then it goes out. So 12 of the 400 something have been outside China. Human flesh search. Okay. I'm sorry, I didn't name it. In fact, it was very unfortunate because I was at something called a web science conference a couple weeks ago, and I won't get into a long digression on what web science is, but I was presenting a paper on human flesh search right after somebody presented a paper on pornography use on the Chinese internet. And I had to stop for a second. This has nothing to do with that. We've got a better version of this now, but roughly speaking, we've been able to categorize what a lot of these things are, and a lot of them are vanity things. So this one called Net Celebrities is actually pretty cool. What happens is someone says, I saw this pretty girl in the Starbucks in Beijing the other day. Anyone know who she is? And then a whole bunch of people figure out who she is. And the interesting thing about it is it's become very. It sounds like a bad thing, a stalker thing, but these people become net celebrities, right? Because 1 million people are trying to figure out who you are because someone thinks you're really pretty or really interesting. So it's a funny effect. But the more interesting ones are things like, so one of my favorites is a hit and run accident that's happened in a small town in rural China. Okay? So what happened is some of the people there went out and took photos and uploaded them. And then people from police departments and citizens who knew more about this stuff looked at the pictures and started coming back and saying things like, because of what we see over here on this street lamp, it's probably a red car. And other people would say, when you have a hit and run accident, one of the things you look for is someone who hides their car in the garage and you don't see them doing their normal things. And so within, again, 4 or 5 days, they had figured out who did it. caught the person and turned them over to the police in that town. Now, that town didn't have the expertise to do that kind of level of analysis. It took this social organization to do it. So an important social impact. Some of the key clues in some of these things you read about. So the Chinese milk stuff, the Chinese toothpaste stuff. Again, those get reported in the actual newspapers, and then very often kick off an event in this online community that actually helps to identify the culprit. So it's actually become a very important part of things. And it's actually interesting because as I talk to different people from China about it, a lot of people say, we don't know, what are the incentives? Why do people do this? Some of the early ones were financial. But turns out very, very tiny case. So only at the beginning. And once these things became self-perpetuating, they don't tend to be it. In fact, it turns out, so don't worry about these things. The real key thing here is that you can't really figure out what the incentive structure is. There's no obvious thing that says they're doing it for money, they're doing it for social reward. Most of the obvious things don't seem to play out. Just for example, there's very few people who seem to participate event to event. So there's some people who now run some sites for announcing events and trying to get them to take off, sort of almost like the award sites you've seen. So you can now find sites on the web that say, do you have a good idea? If you can do this, we'll give you $5,000. If you can do this, we'll give you $1,000. This is almost the same thing. Here's 5 or 6 things we think might be interesting, and some of them set off these searches and some of them don't. Okay, and we've been trying to analyze the incentive structure without a lot of success. Another thing that's interesting, I added this slide today because I know a lot about what George and Eugene and some of the other people here are doing with network analysis. When you actually look at the first pass networks of blogs, wikis, some of the community question answering, online social networks, et cetera, you get that sort of main social network, small world, scale-free, power law stuff that we're all so familiar with. If we know this stuff, and if you don't know what any of those words mean, don't worry about it. But the interesting thing is when you drill down to the dynamics, what you see is this thing looks very different. It's certainly scale-free like the others, but it seems to have a very small number of hubs, a large number of low-degree nodes, very fast growth, quick response times, and each one seems to be separate. So the community doesn't stay together and say, hey, we did a great job, let's go do the next one together. So it's just a community of individuals. But it's had tremendous effect, right? So as we've studied this, what we see, so sort of so what do we learn from that? What does that tell us, right? So remember my goal. I want to see if we can build technology to sort of make it easier to do that sort of stuff, but in a purposeful way. And what we know is pretty much from the dynamics of the human flesh search stuff that, well, I guess there's a couple things I say. One is we've learned a lot of stuff we don't know, right? Stuff that social scientists know we don't know, that computer scientists know we don't know. And we're working with groups of people, this very interdisciplinary stuff. And something interesting is going on here. Clearly has a cultural bias because there have been people who've tried to launch this in other countries and it just mostly hasn't worked. There have been a few scattered reports of successes, but in China it's become a major phenomena. And one of the things is very hard to count how many participants each episode has. Again, because if I had the same chat tag, so a lot of this happens in chat rooms or the same website. So imagine in Twitter, if always it was J.A. Hendler sending the tweet, you'd be fine. But a lot of these people have a lot of different identities, play differently on different sites, things like that. So no one's quite sure the numbers, but the estimate is in the millions. I mean, it's a very large population. A lot of people seem to be involved in this. Some of them very peripherally, some of them very significantly. Again, same kind of numbers you see if you look at Wikipedias and things like that. So something is going on here interesting, and we don't know what it is. What we do know is that there's some dynamic stuff in here that we have to understand if we're ever going to make this stuff purposeful. So what the heck are the incentives? Right? The DARPA 10 balloons thing. So DARPA put 10 balloons around the US and said, $40,000 to whoever finds them fastest. And within essentially about a day after it was really kicked off, they were found by a group at MIT. And what the MIT guys is, they basically took the $40,000 and said, why don't we just split it up among everyone who helps? So the way it works is if you tell us where a balloon is, you get a certain amount of money. If you tell us If you sent, if you told someone we're looking for balloons, right, and they found the balloon, then you get half that amount, and et cetera, et cetera. So they basically just divided the 40,000 by the network that happened, and were able to find it. So in a sense, that's a really good example of an HFS that happened in America. It was just a little too targeted and had one interesting thing. But the incentive structure there was pretty obvious, right? The MIT guys wanted to win this thing, and they were willing to give the money away, and most of the participants in it were willing to tell their friends, because what the heck, I send one Facebook thing to a bunch of my friends, and maybe I'll get $3,000 or $4,000. That's not a bad deal, okay? But one of the things that has traditionally been the case, so if you look at something like Galaxy Zoo, you have a real what's called an expert to novice continuum is the term the social scientists use there. So the astronomers know a lot, are empowering the public to help them. But when you look at something like HFS, you don't see that effect, right? You see different levels of expertise and people coming and going and things like that. So what's going on there? Trust and distrust is talked about, useful. How do you prevent abuses? One of the really neat things in the flash search stuff was periodically people try to exploit it and it sort of self-corrects. So what happened is early on, as it started taking off, a bunch of people said, hey, I hate my philandering husband. Why don't I put his picture on there and say, could you find who this web celebrity is dating? Right? And that sort of kicked off, and then it got reported people were doing that. So now, later, when you actually look at the evolution of this, almost all of the searches now are kicked off by events that are coming from an authoritative source, usually a newspaper reporter. So a newspaper reporter says, there was a hit and run accident. And the people who post the first slides point at the newspaper article and say, this is where it happened. And the newspaper says, yes, that's the case. So again, so they've self-corrected. They've designed mechanisms for authority and things like that. And again, they vary a lot. There's not enough, commonality to say anything really deep about it. But we do see in most of these sites that Wikipedia's, this stuff, games, you seem to have expertise growing, and you seem to see a trust of certain kind of experts, and you see efforts to abuse these things taken pretty seriously by their communities. And another thing is governance. So governance is a really interesting factor in these things. So one of the stories things I like, got me thinking about a lot of this stuff is if you look at Wikipedia, right, and it's been really successful. A lot of people use it, things like that. You can get the exact technology it's built on. You can build your own Wikipedia open source. You just download MediaWiki, you download some of their stuff. And so lots and lots of groups have tried to create a Wikipedia of their own in different communities. Lots of groups have tried to use it within the enterprise. Most efforts have failed, right? So it's pretty clear that what caused Wikipedia to be a success is not solely a technology thing. It's clearly something that interacts between the technology and the social rules and the way it's run. Now, Wikipedia has a government, right? The way a human community has a government. There's people who have authority. There's people who are allowed to lock down. So when Colbert gets on TV and says, everybody please go change it to say that there are more elephants than there were 3 years ago, 100,000 people changed the page and 100,000 changed it back, and it went back and forth. So Wikipedia locked it down. Can't change that page anymore without some effort, okay? If someone vandalizes pages, they usually find it. And they're using a lot of underlying technology to do it. It's clear that a lot of data mining of the history logs is going on, because there's a lot of articles there. It's not the case that everybody's looking at them every day. So they're using a bunch of agents, robots, crawlers, whatever you want to call them, to go through the data set and say, so a page that hasn't changed in a long time and then has major changes should probably have some human look at it. Right? It may have been vandalized, or it may have been updated. Either one of those things kicks off something. The policies are on the wiki. You can go read them in human readable form. It will tell you if you make this kind of change, it will be taken down. If you don't do this, and they've changed over time. So in the most authoritative study of this was by Butler et al. In 2008. They said there were 44 policies and 248 guidelines. I did a quick count back in March. It was 51 policies and over 400 guidelines. So, so it's an evolving government, which is interesting because most human governments offline don't evolve, right? Or evolve slowly, or change in interesting ways. So the notion that an online community needs to be monitored and run is an interesting thing. Now, one of the problems is you can study Wikipedia's governance. There's lots of good papers about it, including that one. You can't download it. You can't have their programs to use yourself. Right? So if you want to build one of these, you can understand how they do it, but you need a pretty sophisticated programming network, and you need your own kind of evolution. So there's no reason yours will grow exactly like Wikipedia. And there have been some very significant phase transitions in the history of Wikipedia. So there have been times where a new rule basically changed a lot of stuff organizationally. So hierarchy used to be very not really encouraged and not really heavily used. So saying one of these is, this is a president kind of thing, was because people got a lot of that wrong. But now they're pushing more of that because they found once they had enough categories, people were doing a better job and things like that. So again, there's a good Wikipedia page on papers written about Wikipedia with hundreds of them listed. But again, it's descriptive of that one site. Right? And I don't know of any work that has looked at 50 different wiki projects, some which worked and some which didn't, and tried to categorize the commonality. So there's not a lot that comes out of Wikipedia that will help you design your system. There's a lot of post hoc stuff that will help you understand what it did. And that's not surprising because the people who study sort of what things did tend to be social scientists, and social sciences, again, painting with a very broad brush, tends to be qualitative and tends to be focused on a retrospective analysis. Now, I'm an engineer. I don't want somebody to tell me that a authoritative incentive system with XYZ was useful in that wiki. I want them to tell me, if you want to build one of these and help people make it work, you should have a mechanism that does this, or you should think about how to do that. Right? So one of the things we need is the rule book for this stuff, right? The terminology, the way people build these things. So, so I already said most of this, but here's again, just closing my loop a little bit again. So here's an example of one of those in Wikipedia. How do you prevent people from ruining articles? And I mentioned robots go over it, but notice we're right back to the thing I started with. What do I mean by software does, or people do the creative work and the machine does an administration? There's a beautiful example, right? Software robots go through and look for defacement. People all look at that to decide whether it really was that, and was it meaningful, and was it abuse, or was it a good edit. Turning over to the technical side again. I mentioned, so again, if you want to build your Wikipedia, right, and have that governance structure, it costs a lot. Scalability is very hard. You need a bunch of back-end machines, and you need that with cloud and things like that is getting easier, but you still need, what's the declarative mechanism? What's the way you write down the rules of one of these things? So if you want to do a galaxy zoo for your field, I hope you have a funding agency that has a lot of money and is willing to let you do it. Right? And that will probably work for biology and chemistry, or for the first one of these in a lot of fields. But if you think about the web, right, the interesting thing isn't the great example like Galaxy Zoo. It's when it can be hundreds or thousands of examples of these used by whoever wants. Right? It was when you could create a web page that things got interesting, not when CERN could create a web page. Right? I remember I got on the web, pretty late in the game. There were over 100 of these things out there. Right? You could go to the web page at CERN, which was the index page. No one had a search engine. No one even had bookmarks. And there were 100 things listed there. And you could click on one. You could see cool stuff, and you could link around. Right? It was a neat demo, pre-Mosaic, and then Mosaic came along and made it easier. And all of a sudden, this thing started growing like crazy, because you could easily create pretty good stuff. Now, before that, there had been, George was talking about this earlier today on one of the groups we were talking to. There were these amazing ebooks, much better than the web. We call them ebooks now. Back then, they had other names. So the Hypertext Conference predates the web, not postdates the web. And the hypertext community had these amazing, so DARPA gave to a group at Brown University $1 million, and that was real money back then. This was 70, I guess mid-80s, to do like a tank manual. And you could see, the thing would open and the guy would reach in his hand like that, and it would sort of point down where you need to look at, and you could link to, depending what you found, you could click on what you'd say, my meter says 27, and it would say, okay, click here, and it would take you to what to do if your meter is below 30 and things like that. Beautiful stuff. You can't find stuff like that anymore. That's not true. The Alice in Wonderland, the paid version of Alice in Wonderland for the iPad is getting close. But, amazing stuff. But there's not a lot of people who have $1 million to build a manual for one thing. And the reason the military got out of it was, in fact, because they realized that $1 million for the tank, and then $1 million when the tank gets updated, and then $1 million for the next, the Bradley fighting vehicle, and $1 million for this, and $1 million, runs into real money pretty soon, right? So what the web was sort of a good solution for everybody rather than a great solution for anybody. We don't know what the good solutions are in this kind of space, right? GWAP, Game with a Purpose, again, black art. How do you make a good one? Right? There have been a lot of efforts and some work, and by the way, it's a real programming challenge. Imagine having a little declarative thing so you could easily throw them together, even a library. Right? I went looking for a Games with a Purpose library because I know a lot of people who built them. Can't find one. Or there may be one by now. They couldn't about a year ago find one. So I can't, because you could try creating 10 of them real quick or 10 variants and see what works. No one's doing that because they're so expensive to do. And of course, how do we create the tool for the community itself? So I'm a cancer researcher. Maybe I have a big team and a lot of money. I'm a cancer sufferer. I don't have a lot of money necessarily. I'm a social organizer on the south side of the city of Chicago. And I'd like to know, is there any demographically matching area in the world that's found some useful way to reduce their crime that I could look at and see if it was helpful? Even better, imagine if I could find one that's in another country and use some of these web translation tools, and there's some new people. There's people playing with cultural things. So colors have different implications in different countries, and there's actually this pretty cool website where when you change the language, it also changes the style sheet so that the colors change. So a color that would represent mourning in one country. So black in America would be changed to white, I think it is, in Japan, or red. Somebody correct me. I forget what's where, but again, so neat stuff like that, or the Windows shift where they label things. So if you go to a country that's left to right, the thing's here, and if you go to a country that's right to left, the thing is here, that kind of thing. So a lot of that's been going on, but again, so those are little easy to grab web forms, but how do you get them to trigger when you're doing these kind of things? You have to be a web designer right now to know about a lot of this. And I'd like to get to where a webmaster could do this. I'm not really thinking it's an end user, just like most end users don't know how to create their own web page. They know how to use a wiki software. But so how could a group of us have the technology that would let us get together and do some of these things? Underlying models. So one of the things I've been talking about with Joan Feigenbaum down at Yale, and we kind of flirt with every now and then, and we keep writing grant proposals that get turned down because we're told we're crazy, is how do we define this stuff more rigorously? Right? So there's a lot of work on networking and social things, but not really on social protocols. Right? Not really on this sort of what would it mean to have governance in a declarative form, and how would you then prove things about it, and how would you analyze what was going on? I think I've already said some of these. So I tend to come from from an engineering point of view, right? So what I really want is underlying architectural principles that will help guide the design and engineering of this web's infrastructure, right? I know this stuff has to be distributed, open, dynamic. I know that some very lightweight tools like wikis and chat groups have been used in the past to make this work. Again, going back to HSF or Wikipedia. And I'd also love to figure out how we kind of make sure that so I haven't gone into this direction so much in this talk because I figured this was more of a technical audience, but there's kind of social policy expectations, right? So one of the things is This is a cultural different thing like that. But so if you're so look at the stuff, look at the flare up going around right now about Facebook changing some of its general privacy approach. Right? There being, there are congressional bills now to prohibit it. There's user communities who are demanding it. Most of us don't understand it, and if you study it carefully or you go read, Dana Boyd's blog, you'll see all sorts of great arguments about this stuff one way or the other. The argument in favor is a lot of people can make a lot of money off of it, but they won't say it that way. What they'll typically say is we can save you a lot of money off of it, which is true. So people are figuring out how do you turn your social capital into money now? And if this stuff is open, then what can happen is I sell shoes on the web. I can say, well, right now they're $35, but you seem to have a lot of friends. If you can get a few more of your friends to buy them in a group with you, I'll sell them to you for $32. Right? That's an advantage to you, and it's an advantage to them. So social compacts and how to commercialize that stuff is thought about. But again, if you knew that buying behavior was going back to some central database that's being data mined, and they're trying to figure out whether your IP address is in there, so they can try to figure out whether your buying behavior. So the fact that you're buying shoes would trigger them to start sending you customized advertising for other things, is that something we all want? And when they find you're buying certain kind of medical things, should we be telling you that that's going on? And should we tell your insurance company? So again, there's a real slippery slope in this stuff. And what are the expectations? What do communities want? If you read the Wikipedia stuff carefully, what you'll see is a lot of their evolution has been driven by exactly that. They say, our community has come to expect this kind of level of quality, which requires this kind of copyright protection, which is why we've installed this new copyright rule. Facebook doesn't feel compelled typically to do that. They simply say, click this new setting, and there's a big fight over opt-in versus opt-out. So I'm getting off into digressions. I won't go there. But typically what you find is if you ask people, click here if you would like X, they typically won't click there. If you say, click here to stop X, so click here for us not to share your stuff. Most people won't click it, things like that. So it's interesting in Northern Europe, particularly in the Scandinavian countries, organ donation is in the 80 to 90% range, and in the U.S. it's in the 10 to 20% range at its best. And one of the big differences is there you have to, when you buy a driver's license, say, and by the way, if I'm in an accident, I don't want to share my organs. In the US, you have to say, if I'm in an accident, I do want to share my organ. And all these studies of this stuff show that to the first order of approximation, because there are lots of other factors involved, that thing seems to be the dominant factor. When you go to opt-in in the US, it changes way up, and if you go to opt-out in the US, it goes up and opt-in. So again, we know a lot of this stuff. We just don't know how to use it, right? So I'm going to skip this stuff. Some of the stuff I've been playing with is trying to think about what we need. The other thing I want to say, so this gets me into what we've been calling web science, and among some friends and I, and luckily now a few thousand other people. In fact, when George introduced me, he actually said something wrong. I'm not the Assistant Dean of Information Technology anymore. I'm the Assistant Dean of Information Technology and Web Science. We have renamed the program, and we are emphasizing a lot more of this social aspect, that to understand the web, not to design web pages. That's not what it's about. It's about really understanding the web. You have to understand the underlying mathematics, the engineering principles, and the social stuff. So you need all this stuff. Right? It's not enough to read Kleinberg, and it's not enough to read Berners-Lee, and it's not enough to read your favorite social scientist, and not enough to go out for an economics or a law journal. It seems like we got to get those communities talking to understand it, because we can't solve the kind of problem I'm showing you until we know incentives. Well, incentives are primarily studied by social scientists and economists, but I also need to figure out how do I turn those incentives into something that works on the web. Well, that's where the games with a purpose and things like that come. You can see pretty easily it shouldn't be too hard to come up with some kind of library in that space or things like that. So there's a lot of other technical stuff I've left off of this. We're looking at, sort of what are social rules? Can you make, so one of the issues is I mentioned that we'd like to get that governance stuff. Could we make that explicit? So it'd be really nice if you had some sort of simple rule system declarative. So so if you had a system that was working, I could take your system and the underlying technology would come in. And then if I want to make some changes, that would also help change the underlying rules. So we're looking at that. The dynamics of web-based social networks, there's probably people in the room who know far more about it than I do, but that's something which some people have started looking at. It's very interesting as to what affects and changes things. We've been playing with some, modeling large communities. So what's really annoying if you want to try to model a community of 400 million agents doing something is that it's really hard to, it's not necessarily hard to come up with the formula per agent, but to run 400 million of them on your laptop takes a while. So we've been using supercomputers and clouds and things like that to try to explore some of this stuff. But most supercomputing technology assumes is not built around that kind of discrete agenty stuff. It's primarily built about networks of equations and things like that. So most supercomputing isn't used by computer scientists to solve their problems. It's typically done by physicists to solve theirs. So we're looking at that. And finally, again, how can we, just traditional theory of computing doesn't allow humans, right, very easily. So you can't say, I have this Turing machine, and by the way, depending, whether it goes to the next state or not will depend on what Fred says. Right? It's very hard to analyze one of those and not end up undecidable. But there's actually some interesting things that are starting to be done about Oracle Turing machines, things like that. So Joan and I have been exploring that. So to conclude, I really truly believe that there's some really exciting stuff out there. We're on the cusp of some of this new technology. I think these will really be transformative technologies if we can get this stuff right. I hope I've tried to convince you that, again, I didn't show you how we cure cancer because I don't know how to cure cancer. I didn't show you how we solve a social problem because I don't know how to solve those. But what I hope I've shown you is that the technology deployed correctly with the right kind of tooling and the right kind of understanding might get us to where the web could really be harnessed in this new and different way, purposefully. So we really want to figure out how do we really understand online communities and then how do we enable better work by that. I've shown you there's some important examples, so I think it's not science fiction. But it requires a lot of science, and it's not a science that naturally falls into the traditional bins of academia. So we're going to have to break down some walls and figure out how to work together. And I think it was great. Today I was in George's class, and the book is called, Economics and Social Networks. So we can start pairwise, and then eventually we'll get economics and social theory and social networks, and we'll get computing theory and economics. So again, we need that. We really need to understand how to work together. I like to use the example of climate science. You don't find typically a climate science department with a bunch of people who don't talk to anyone else. What you typically find is oceanographers, atmospherics people, librarians, people from all sorts of different disciplines who happen to be studying the climate using the tools of their groups, and I hope I've convinced you that there's something interesting there. So there's my conclusion. I think that's not science fiction. I think it's real. I think we can make it happen, and I hope over the next decade you'll join me in making stuff. Thank you.
We have time for a few questions, if that's okay with you, Jim.
Sure. Yeah.
Yeah, a couple weeks ago.
Somebody should turn the lights back on.
Up in Burlington, and there was a guy named Ben Cowkett who's from up there who has a company called Quirky, Quirky, that does crowdsourced product development. I was just wondering if you know about them, what you think about their social machine.
I don't know their stuff well enough, and even if I did, I tend not to answer those kind of questions at that level, just because. Sometimes something's the first, sometimes it's the best, so once something's a Google or something, it's a lot easier to say they're doing great stuff. But I'll point to specialized technologies and things. I just don't know that one very well. But it's an idea that's coming, but most of it still is evolving out of the traditional social network platforms. And I think the much more interesting thing is to start doing it. There's some data sets I'd love to get my hands on, and I wish a lot more of these companies would tell us. So Ning, which sort of create your own social network, claims they have 900,000 or whatever their number is of social networks in there. Boy, wouldn't it be nice to have their dynamics and know how many succeeded, how many failed, what they looked like. And so again, a lot of small companies are talking to those big companies, getting access to some of that stuff and trying to figure out how to use that kind of knowledge to commercialize. So I don't know so again, I went to Quirky site once, but to be honest, I don't remember what they're doing. There's also a lot of prize sites and things like that. So again, I'll take a look later.
One of the more interesting things that they have is just an incentive structure for people who contribute to product development.
Okay.
So that's,
Yeah, again, a lot of things. But we still don't know what the incentive structure is for this stupid World Wide Web thing, which seems to be getting a lot of people using it. And all of the early predictions about why it wouldn't work seem to have fallen by the wayside, and they were almost all because the incentive structure wouldn't work. So by what we knew pre-web, right, we were pretty sure. So again, if you didn't pay, so why didn't Ted Nelson, some of you may have heard of him, Ted Nelson almost had the web 10 years before Tim did. And there were some technical issues he didn't have quite right, but the biggest issue is he couldn't let go of the fact that you had to give this stuff away for free to get it to start. He wanted to figure out how people would make money with it, because the only incentive he could come up with for people to put information on the web is they get paid for it, right? And Semantic Web, people kept saying, well, what's the economic model? I said, once we get enough of that stuff out there, people will figure that out. Sorry, question, yeah?
On any given day, there must be a number of hidden accidents and things like that. So how do they keep enough? How do they keep them on the forefront to be able to concentrate the effort?
I'd love to be able to answer that question. And again, if you saw those numbers I showed, and if we'd really drilled down, what you'll see is, that a lot of the early ones were more socially relevant, and a lot of the later ones are now, so now it's a phenomenon where you can get, well known on the web by doing something and kicking off one of these. So, it seems to be trending that direction. So things like that. So it's a little hard to answer that question, but there's still a fair amount of social activism on the thing. And some people I talk to say that's because in China we have this very strong cultural urge to help the world, and other people tell me it's because in China we have this very repressive government which doesn't like us doing this stuff, so it's sort of an act of rebellion. So again, I don't have a good answer, but what I can tell you is that there's not really been a lot of evidence we found yet as to which things will kick one off. In fact, when we have this has been accepted in a major publication, sort of our first version of this, and we're working on a longer version now. And my Chinese colleagues are really nervous that this is going to kick off a who are these guys thing. And they don't know whether they want to or don't want to be, that kind of fleeting fame. So, it's a very interesting phenomenon. I'm lucky that culturally I don't have to play. We don't really know. But a lot of the other thing is, again, it becomes purposive. So a lot of newspapers now work together with these communities, which turns off some of these communities. They've stopped helping because they didn't want to be whatever incentive they had, it wasn't to help the newspaper sell more things. So when they felt they were helping investigative journalism break big stories, they felt very differently than when people started expecting them to help, things like that. So there's a lot of room to explore here. Again, why a science site like Galaxy Zoo gets so many users, where people who've tried this in a lot of more commercial things stuff haven't succeeded, again, hard to answer.
Yeah, I was just curious, do you have any way of telling the difference between a growing user base and people who have remained in there? Because it seems that in a lot of things I've seen, you're in there for a while and then you get turned off, but others are coming in, so it still looks like it's growing, but it's not lasting.
Yeah, again, hard to answer some of those questions without data that's not available. It's actually, one of the reasons it's easier to study this stuff in China is you are able to get some of this data. So for example, in the US, to grab that stuff off a chat group in MyNet would require coming up with a legal agreement with the companies running and things like that. China, you can stick a sniffer out there and grab it and you won't go to jail. But on the other hand, if you abuse that information, people will get very angry. So again, it's hard to answer that. But what happens is if you look at the accelerating curve and look at sort of the number of participants and things like that. So, in the past 6 months, we found as many of them as in the year before, as many of these episodes, and each episode seems to be at least as big or bigger. So that argues for more people, whether it's new people coming in, twice as many coming in every year, or whether it's some staying in and some coming, that's not yet answerable. And again, I think setting up some of these things, studying some of this, one of the things that's really neat on the web, so one of my students was doing a piece of work on trust, and we were doing the traditional IRBs and things like that and getting 20 or 30 people and running these controlled experiments. And finally she said, let's get an IRB to put up a website, and we'll get a whole bunch of people, we'll do the viral thing to get 1,000 users, and then we'll analyze what it looks like when we have 1,000 people on it. We'll tell them we're going to do it, and there'll be a self-selection bias and all that, but at least we'll know whether we're barking up the wrong tree or not. So again, and Music Lab, the stuff done for music dissemination by Duncan Watt and others was similar kinds of things. So on the web now we can run experiments with very large N's if we're careful, and companies can run experiments with very large N without getting an IRB. They just call it a new product. We have to be, as academics, be careful. But I think we can study a lot of this stuff by just trying things, and so that's what some of my students are now playing. We're looking at taking government data, because that's something else I do a lot of, and saying if we can make visualizations of government data, and if we can let people interact with that, could we kick off some of this virtuous cycle stuff? But we haven't cracked it yet. So far, the government loves what we're doing, but none of them have a big following. Yeah.
So a lot of the examples you give are fairly simple problems, specific problems that are solved. And what's new is that these mechanisms of software and data are being created that are harnessing collective intelligence of users. Is there an extension of that which goes beyond that to be more predictive, where the web itself, rather than relying on the active collusion of humans, becomes more of a predictive than any other? Sort of encapsulates data and is able to ask questions itself.
Cool. You a student or a professor? No, yeah. If you're a student, study it. If you're a professor, get a bunch of your students to do it. And tell me how it goes, because I'd love to see it. Again, what I will say is it's pretty obvious from this talk, I hope, that this is very early in this stuff, and that there's an awful lot of different ways it could go and grow. And I mean, I hope it's been a vision talk, not a talk where you think, gee, that guy has an interesting research group which has done 2 interesting things. I mean, it's really, I'd like to stimulate thinking along these lines. I'd like lots of people to come up with great ideas to try, because frankly, I don't, I mean, me and the MacArthur guys I was hanging out with don't know how to solve this problem. We have some ideas to get it started, and some of us are giving talks like this, but it's exciting, right? I mean, imagine really doing it. And I can show you some other. I mean, I picked galaxies. There's a lot of you have probably heard of Patients Like Me, which is you go on, you say some stuff about a condition you have, and it tries to match you up and find a community, and essentially in exchange for you being willing to open up some of your health information to them, they're willing to help you find other people. But there's been now things that take those what's been learned from that and are doing things like matching people to clinical trials. And when you start reading, testimonials that say, "Thank you, your website saved my kid's life," you start seeing community stuff can really be powerful. And if we can really figure out how to do this stuff, and evil, I mean, this is the web, right? There's a bunch of guys on the web who don't believe what I believe. I believe that, the purpose of one of these community sites will be jihad, or again, the only thing I'd say about that is they, by bringing all these things out into the public and transparent, that's another way to do it. So again, anything on the web that has tried to be, for good only has failed, because the problem is the different people in the world have different ideas what for good only is, things like that. So again, a lot of interesting things.
Well, I was going to take the question of good and evil and flip it a little bit. Obviously, we can use this collective intelligence to do social good, but governments can use it to do all sorts of.
Yeah,
whether it's good or evil, it's nebulous.
Yeah, I'll give you my. I'll end with my favorite web story. This is what got me into becoming a real Webby, right? So people say that, when I started giving this talk, it's when I transitioned from a computer scientist to a web scientist, about going on 20 years ago now, yeah, 19. But I was proposing some of this agency stuff and web stuff in the early days of the web, and someone else was giving a talk, and their talk was called How Many Cows Are in Texas? And they were saying, why don't we get the web to answer questions? So we data mine all the things, and you'll see this comes up periodically, right? And I thought, and they said, how many cows are in Texas? And there's not, and they were able to find some web documents that answered. It was pretty cool, and if you type that to Google nowadays, you'll find a lot of things. There was a period of time where the only thing that would, the top hit on that was my talk about it, but now there's plenty of other things. But back in the days I first tried it, Google didn't exist yet. Was not, Sergey Brin wasn't even in college yet. The Alta Vista, I guess it was just in college. Alta Vista, among the top 20 hits was a website that said there were no cows in Texas. They've been replaced by alien symbiotes, and that's why you shouldn't eat meat. Right? Now, most of us laugh at that. But what I realized is what made the web is that a radical ufologist vegetarian, right, had as much right to be on the web and to create a web page and have their opinions out there as I did. Right? Because to someone else, what I believe is radical vegetarian ufology. Right? So the minute we let anybody own the web, nobody can play. Right? The flat worlders won't allow the round worlders, and this religion won't allow that religion, and the pro-X's won't allow the anti-X's, and sort of who makes the decisions. And so one of the real social changers of the web was that it can only work if you'll take the good with the bad. Right? And if you enable things. But one of the things we've seen is that it can also enable a lot of transparency of that stuff. So it's hard to hide that something is going on the web. So if you'd like to use it to organize jihadi, that's fine, but you should realize there's going to be a lot of other people searching out people who are trying to organize jihadi on it, and if more of us are trying to find it than are trying to use it, that gives us a social advantage. So again, there's a little bit of self-correction there, but it's a big issue, and I admit it freely. And you notice I said, in my slides, I had one place that said, got to meet the social expectations of your community, right? Because you can't build that in across all communities. They're different, culturally, technically, et cetera. So again, I'll stop there because I can talk about this forever. Thank you.